In this video, you will learn about significant figures. But before that, I will first discuss the kinds of numbers. Three kinds of numbers are encountered in chemistry and in everyday life. We have the counted, defined, and measured. Counted items are expressed as exact whole numbers. For example, 5 test tubes. Another example, 12 books. And another example, 10 fingers. So those are all counted items. Next, define relations. So these are exact numbers but not always whole numbers. These numbers come from the definition. For example, there are 12 inches per foot, or there are 2.54 centimeters in 1 inch. So that is an example of a defined relation. And lastly, we have the measured numbers. So these are obtained from reading measuring devices. So these numbers are never exact. So those are the three kinds of numbers. All the digits that are part of a measurement are considered significant figures or significant digits. So the following are the rules for determining the number of significant figures of a measurement. First, every non-zero digit in a reported measurement is significant. Examples: we have 791.32 meters has 5 significant digits because 7, 9, 1, 3, and 2 are all non-zero digits. Another, 563 centimeters. So we have 3 significant digits. We have 5, 6, and 3. Next, leftmost zeros before the first non-zero digit are not significant. They only act as placeholders to show the position of the decimal. Examples: 0.089 grams has two significant digits. We only have 8 and 9 as significant digits. So the two zeros are not significant because first, the zero on the leftmost of the decimal point is not significant. And another one, the zero on the leftmost of the first non-zero digit is not significant. So we have 8 as the first non-zero digit. Therefore, the zero on its left will not be significant. So we only have 8 and 9 as significant digits. Another example, we have 0.0009 has one significant digit, which is 9. So the 0 on the leftmost of the decimal point is not significant, and the zeros before the first non-zero digit, which is 9, are not significant. Next. So zeros in between non-zero digits are significant. Examples: we have 0.005006 meter has 4 significant digits. So the two zeros between 5 and 6 are significant. Therefore, we have 4 significant digits. Another example, 46,073 meters has 5 significant digits. So the zero between 6 and 7 will be significant. So we have 4, 6, 0, 7, and 3 as the significant digits. Next, zeros to the right of a non-zero digit and to the right of the decimal point are significant. Examples: we have 36.00 centimeters has 4 significant digits. So the two zeros on the right of the decimal point will be significant. Therefore, 36.00 has 4 significant digits. Another example, 0.350 has 3 significant digits. We have 3, 5, and 0. So 0 to the right of the non-zero digit, which is 5, will be significant. And last example, we have 310.009 milliliters has 6 significant digits. So all digits are significant because first, the 0 after 1 is significant because the 0 to the right of a non-zero digit is significant. Then the two zeros to the right of the decimal point are all significant. And lastly, zeros at the rightmost end of a measurement that lie to the left of an understood decimal point are not significant if they serve as placeholders. If such zeros were known measured values, then they would be significant. These values can be clarified as significant if they are written in scientific notation. Examples: we have 80,000 meters has only one significant digit. So the whole number 80,000 has an understood decimal point after the last digit, which is 0. Therefore, zeros to the left of the decimal point or the understood decimal point are not significant. So only 8 is significant. Another example, we have 43,320 meters has 4 significant digits. So the 0 on the last digit is not significant because we have an understood decimal point after the last digit, which is 0. And then the 0 to the left of that understood decimal point will not be significant. Therefore, the significant digits are 4, 3, 3, and 2. And lastly, we have 1.000 times 10 raised to 3 meters has 4 significant digits. So we have 1, 0, 0, and 0 as significant digits because these values can be clarified as significant if they are written in scientific notation. So that is about scientific notation. Thank you for watching and I hope you have learned something.